I have just previously been summoned back to the grave, and I lost my English accent trying to mix in with the 21st century. Today I'm going to teach you about my three laws of motion: the law of inertia, the law of acceleration, and the law of an opposite force. Now, through this entire video, I'm probably going to use this football. And I'm going to show you how these laws have been interpreted through 21st century or common day experiences. These laws might seem confusing to you at first. I know they were to me, and I invented them. So, let's go look at the fabulous, or not so fabulous, world of my three laws of motion. So, let's discuss my first law of motion, the law of inertia. We're going to use this football. This law states that an object at motion will stay at motion at the same speed and direction until an unbalanced force is acted upon it. An object at rest will stay at rest until an unbalanced force is acted upon it. Now, let's start with the rest part. I'm going to put this ball on the floor. It's at rest, and it won't move. It doesn't move until an unbalanced force acts upon it. What my law states is basically when an object is still, it will remain still until something moves it. The unbalanced force that's going to move it is method. Watch. As you can see, the ball moved. I kicked it. It's basically a very simple rule once you break it down a little. Now let's go on to the second part. The second part of this law states that an object in motion will stay at motion until an unbalanced force is acted upon it at the same speed and direction. I'm going to throw this ball up in the air and it's going to land somewhere over there. Now it's going to go in the same speed and at the same direction, and it's going to stay constant until it falls on the floor. It'll probably flop a little, but that's okay. Now, let's start. As you can see, there are two things to learn from here. One, Isaac Newton is not a very good football thrower. And two, the unbalanced force that brought the ball down and then made it bounce is called gravity. And yes, believe it or not, gravity is an unbalanced force that can act upon movement. It acts upon many things. Now, inertia is the resistance to change in motion that all objects have. That's a very, very strange or tricky phrase. What that means is that, how do I put this? Okay. So, say your mom is in a car, and she is driving. She comes to a sudden stop. Your body goes forward, right? And then the seatbelt pulls you back. That is an example of inertia. Even though the car has stopped, your body is resisting to the change in motion. It goes forward, but the seatbelt keeps you back. So, yes. Now that you know my first law of inertia, let's go to my second law of motion, the law of acceleration. Let's discuss my second law of motion, the law of acceleration. This law states that the higher the mass of something, the more force has to be used to accelerate it. Acceleration is caused when force acts upon a mass. What this basically means is to move something, you need to put force upon a mass. Now, to show this example, I will, A, tell you the equation that I used to calculate force, and B, keep a football and keep a house roughly at the same time. Now, the method, or the problem I used to solve this, is F equals ma, or force equals mass times acceleration. The unit that you would use to calculate force is a capital N, or newtons. Now, let's go to the example. This football in this house. And you might be thinking, this is a little dramatic, isn't it? No, it's not. The house has a higher mass, the football doesn't. It's going to be easier to move the football than the house. And that is what we're going to be trying to do. We're going to see how much force it's going to take me to move this football and to move the house. Watch this again. Okay. Now I'm going to try to move the house. Nothing. Because humans don't really have the power in their foot to move a ginormous house. That's a perfect example, because to move heavier objects, you need to put more force upon them. And to put more force upon them, you have to work harder. That's generally why when you move heavy objects, it takes a lot more time and somewhat more pressure. So, yes, that is my second law of motion. Now let's go on to my third law of motion, the law of an opposite force. So let us discuss my third and final law of motion, the law of opposite force, or opposite reaction, opposite whatever. Basically, it states that with every action, there is an equal and opposite reaction, and this law is basically self-explanatory. With every action, there is an equal reaction. If something hits another thing, one will go one way, and then the other will go the other way at the exact same speed and direction, until gravity or whatever unbalanced force puts it back down. We're going to use these two rocks here. They're not the same size, obviously, what two rocks are, but they're the same weight. About, like, 0.5 pound rock. Ready? Watch. If you didn't see the opposite reaction, I will show you that. Now, if you didn't see it the first and second time, I'm not going to do it the third time. Instead, what I'm going to do is I'm going to explain to you what happened in super slow motion. The rocks, what they basically did was they hit, came together, spread apart just a teensy-weensy bit, probably moved that way, and then fell. Now, the reaction in that was when the rocks split apart in a split second and then fell. Well, yeah. Another example of this would be a rocket. The flame of a rocket goes one way, and the opposite and equal reaction is the rocket going the other way. But we weren't going to make a rocket. It's too complicated. It won't take too much time. So, I guess that concludes our video on my 3 laws of motion. I hope you learned something here today, and if you didn't, well, then read a book. You'll learn something. Sincerely yours, Sir Isaac Newton.
I know you want pop, you want rock and roll.
You want it?
This year's remix
Got some phonics.
soul. I got pop, I got rockin'
Electronic.
beats. I got your pop music with the future flow.
So don't worry, even if the sky is falling down.